Welcome to the video demo of Big Monitoring Fabric IPFIX generation service by Big Switch Networks. Big Monitoring Fabric, or Big Mon, is architected ground up for hybrid cloud visibility and security, delivering cloud-style monitoring as a service. It enables IT operators to pervasively monitor all application traffic by gaining complete visibility into physical, virtual, and cloud environments. One of the components of the Big Mon is the Big Mon Service Node that offers highly performant, scale-out advanced packet services like packet deduplication, packet slicing, header stripping, Netflow generation, etc. on industry-standard x86 hardware. Once connected to the fabric, the service node is automatically discovered by the Big Mon controller. Now let's take a closer look at the FlowGeneration services available on the service node. Big Mon Service Node supports Netflow version 5 and IPFIX generation. One way to get flow-level visibility for production network is to enable Netflow or IPFIX on the production network switches and routers. Generating flows on production switches or routers can strain resources, which can lead to packet drops. To avoid severely constraining host CPU, switches and routers typically sample the traffic for flow information extraction, which can lead to missing short-lived flows. Also, most production networks consist of different switch and router vendors, which can lead to inconsistent Netflow or IPFIX versioning. Netflow and IPFIX feature on service node can be used to generate one-to-one flow records from production network. This offloads routers and switches from FlowGeneration and also provides full flow level visibility into production network. Flow versioning consistency is also achieved when flow is generated at service node. To generate flow data, traffic is tapped or spanned from production network and forwarded to service node via policy. Once the production traffic arrives at the service node, flow records are generated and sent to the collector. For our demo, we will generate IPFIX records from our production network. We will use Big Mon Analytics node as IPFIX collector for visualization. On the Fabric menu and Netflow tab, we see that all dashboards for this page is empty. Now let's configure IPFIX service from Big Mon GUI. From Big Tab menu, we select Manage Services, which gets us to Manage Services page. Devices table gives us information on how many service nodes are connected to the Fabric and which ports from Fabric are connected to the service node. Before creating the Manage Service for IPFIX, we will create IPFIX template. We will name the template as Production Template and provide the template ID of 256. Next, we select keys and fields for the template. This provides flexibility on what data user wants to extract from the packet flow. For keys, we will select source and destination IP address and transport port along with IP protocol. For fields, we will select packet and byte delta count, flow start and end time, and flow end reason. Now that we have created the template which can be used for IPFIX managed service, let's create the IPFIX service. We will name the service as IPFIX service. Then we select the switch service node is connected to on the fabric and the port on which we want to run the service. Next, we select the action and from the drop-down menu, we select IPFIX. First, we specify the delivery interface. For our demo, this is labeled as IPFIX delivery. Then we select the collector IP address, which for our demo is the Big Mon Analytics node. For a flow which is not getting any packets, user has the option to select the timeout. We will leave hours to 15 seconds. For long-day flows, active timeout can be configured to desired value so that collector can get information for the flow sooner rather than later. We will assign the UDP port number of 4739, which is the default for IPFIX. IPFIX template table enables user to select the template for the IPFIX managed service. For our demo, we will select production template, which we created earlier, and save the IPFIX service. From the managed service table, we can see that the service has been created. Action for the service is IPFIX, details for IPFIX service, interface the service is running on, and the status of the service. Now that we have created the IPFIX service, let's create a policy which gets traffic from our production network to generate IPFIX records. We give policy a name, IPFIX policy. From the Rules tab, we select the rule. Since we want to generate flow records for all traffic, we select any as the rule. Next, we select filter interfaces where the traffic is tapped or spanned from. For our demo, this is lab feeds. Then, from the Services tab, we select the IPFIX managed service that we created earlier and save the policy. Let's go back to the Discover menu on the Big Mon Analytics node. We see that we are receiving the flow data on the Analytics node. By expanding on one of the flow, we see the details of the flow record along with the flow type and version. Going to the Fabric menu in Netflow tab, we see that Analytics dashboard is now populated. From the dashboard, we can observe who are the top consumers of the network, what are the top apps on the network, and who are the top talkers. To recap, we saw that Big Mon Service Node provides advanced packet manipulation services like IPFIX generation, packet deduplication, and many more which are not available on traditional switching ASIC. By leveraging industry-standard x86 hardware, Big Mon Service Node provides highly performant solution with scale-out architecture. With Zero Touch, Big Mon Service Node is auto-discovered and managed by Big Mon Controller, providing single pane of glass management. This concludes the video demo. To try the hands-on lab with Big Monitoring Fabric, please visit us at labs.bigswitch.com. Thank you for watching this video.